All right, today's focus is long division, and we're going to start this off with a couple of review problems using long division. So you see right here in example 1, we have 92 divided by 2. And if you guys remember, our long division sign looks a little something like this. Got a flat horizontal line with a little hook on the left side. We're going to start by putting our dividend, the 92, underneath our long division sign, and the divisor, number 2, on the left side. And we focus in on the first digit of the dividend, this 9 here, and we think about how many times does 2 go into 9? And in this case, it can only go in there 4 times. Okay, because 4 times 2 is 8. If we add another 2, we'll have 10 and we'll overshoot it. So it gets to 8, but it doesn't get all the way to 9. We need to start thinking about what's left over. So if we do 2 times 4, which is 8, and we subtract it from that 9, we'll be left with 1. We can then drag this 2 that's left over down. And then we start thinking about, okay, how many times does 2 go into 12? Because we are dividing by 2. And in this case, we know that that answer is 6. It goes into 12 6 times. Okay, we can then check and make sure that that doesn't have anything left over. So 2 times 6 is 12. We can subtract it from our previous 12 and confirm that we have 0 left over. And we can leave our answer there at 46. Moving on to example 2, go ahead and try this on your own by pausing the screen and then come back and we'll talk through it. Now that you've had a chance to do this problem, let's talk through it. We'll set up our long division. We'll have our dividend, 1,573 underneath and 13 on the outside. And we can think about first, all right, how many times does 13 go into 1? And it doesn't go into 1 any times, right? 13 is bigger than 1, we can't go into it. So let's slide over. How many times does 13 go into 15? Well, it only goes into it 1 time. So let's put that number up top, 1. And if we put 13 times 1 and subtract that from 15, what we were targeting, we'll be left with 2. We still have the 7 and 3 at the end, so let's pull them down, 273. And that's what we're trying to focus on now, is how many times does 13 go into 273? Okay, focus on the 2 first. 13 doesn't go into 2 any times. It's too big. How many times does 13 go into 27? Well, it goes into it twice. Put the 2 up top. We'll do 2 times 13 to try and figure out how much we have left, which is 26. Okay, and we can subtract 26 from 27. We'll have 1. We'll pull that 3 down with us, and we have 13 left over. So now we're focused on that. How many times does 13 go into 13? Well, it goes into it 1 time. We'll check out, make sure that we don't have any left over after that. So we'll subtract 1 times 13, which is simply 13. Gives us 0 at the bottom. So our answer up top is 121. We can apply this same process to polynomials using the following steps. Go ahead and pause your screen to copy this down, and then we'll talk about these real quick. So when we use long division with polynomials, we want to focus on the first terms, just like we were kind of focusing on the first digits as we were working through. We're going to figure out, okay, how many times does the first term of the divisor go into the first term of the dividend? We'll multiply to figure out kind of how far we got. We'll subtract to figure out how much we have left over, and then we'll continue on and repeat. So let's see how this comes into play for example 3. We'll create our long division sign, and we'll write our dividend underneath, so x squared plus 6x plus 9, and our divisor on the left side, x plus 3. And we want to focus on the first terms here. So this x and x squared is what we're focused on first. So how many times does x go into x squared? Well, it goes into it x times. We need x times x to give us x squared. And I'm going to talk about this at the end, but notice where I am writing my x in my answer right now. We'll come back to that. So now that we've had x plus 3 times x, we're going to see how far that got us. If we do x times x plus 3, we'll get x squared plus 3x. Okay, and we're going to subtract that whole thing from our original dividend to see how much we have left. If we subtract x squared from x squared, we'll have 0. If we subtract 3x from 6x, we'll have 3x left over. We're going to drag down this 9 to write out our new polynomial. Now this polynomial here, 3x plus 9, that's how much we have left. And so we're going to see how many times x plus 3 goes into that. So again, focus on those first terms again. So this x, this 3x is what we want to focus on. And what times x gives us 3x? Well, it's going to be 3. We throw that up top, plus 3 up top. We're going to multiply 3 times our original polynomial to see how far we got. So we'll have 3x plus 9. And we're going to subtract this whole thing from what we were trying to divide into. And if we have 3x minus 3x, we'll get 0. If we have 9 minus 9, we'll get 0. And there's nothing left over. So we successfully divided that. Take a second, look this over, try to work through it again if you're confused, or replay the video. We'll move on to our final example before going into practice. So in example 4, it gets a little more difficult, but the principles hold the same. We're just dealing with longer polynomials. So go ahead and pause your screen if you would like to try this on your own, and then you can compare it back to the work that I do. All right, now that your screen's unpaused, we're going to set up our long division problem first. Okay, we'll put x to the third plus 5x squared plus 7x plus 3 underneath, and I need a little longer sign. We'll have x plus 3 on the left-hand side. All right, again, we're focused on the first terms. So how many times, or what times x gives us x to the third power? This is going to be x squared. Okay, we'll multiply that x squared times x plus 3 to see how far that took us. So that would give us x to the third plus 3x squared. We're going to subtract that whole thing to see what's left. We don't have any x to the third powers left over. So we have 5 minus 3x squareds, okay, which leaves us with 2x squared plus 7x plus 3. The 7x and the 3 is what we dragged down from our original polynomial. All right, now we're focused on first terms again, so we're focusing on what times x gives us 2x squared. Okay, in this case, it's going to be 2x, so let's write that up top, plus 2x. We'll multiply to see how far that got us. We have 2x squared plus 6x. Oh, sorry. That should have been written in red here. 2x squared plus 6x, so I'll put some parentheses around there so we can show that we're subtracting it. Okay, and if I subtract 2x squared from 2x squared, we'll have 0. If I subtract 6x from 7x, we'll just be left with x. The 3 can be dragged down. We just have x plus 3 left. So we repeat this again. And you can see with longer polynomials, we just do the same thing over and over again. We focus on the first term. Okay, how many times does x go into x? It's just 1. So we're going to write 1 as part of our answer. And we multiply to see how far that got us. We have 1 times x is x. Oh, excuse me. Sorry for the technical difficulties there. I've refreshed my screen, brought it back to the problem, rewrote it real quick, so check out where we're at. We had just multiplied 1 times x plus 3 to finish out our problem. Okay, then we subtract that result, x plus 3 from x plus 3, check and see if we have anything left over. We have 0, so that means we don't have anything left over. So our answer is up top here in green, x squared plus 2x plus 1. And I forgot to mention it on this last problem like I promised. But notice how I wrote in my answer like terms above like terms in our dividend. So I didn't write anything above x to the third power. I did write my x to the second power over 5x to the second power. I wrote my 2x over my 7x and my 1 over my 3. And that's not required, but it's something that kind of keeps things orderly as we go through this long process here. So if you're continuing to struggle with this idea, go back, try example 3 again, try example 4 again, and explore Google Classroom for some additional resources as well before moving on to practice problems.